All right, so let's look at these examples. Here we have 25,000 inches. Again, these zeros right here, these are all placeholders. So 25,000 inches has two significant figures. All right, now, here we have an example of a number where we do have a decimal point. There isn't anything to the right of it, but it's there, and this number is 200 years. There will be cases where you will be taking a measurement, and the lowest increment that you measure at does turn out to be a 0. So basically, in this example, we're saying that this measuring device that we had was accurate to the ones place, but that value at the ones place was 0. And whenever that happens, in order to show that that 0 right there is significant, is important to showing the precision of the measuring device, we would put a decimal there to indicate that these are both significant digits. So this value written in that way would have 3 significant digits. The next one, 48,600 gallons. These two zeros, there's no decimal. These are only placeholders. So this would have 3 significant digits. Okay, in the last one, we have 2 captured zeros there, so they are significant. However, these 3 right here are placeholders, and so this value would have 5 significant digits. Okay, so let's double check what we've learned here. All right, in this one, which answers contain 3 significant figures? Okay, looking at this one, we have non-zero digits. Those are all significant. And this is a trailing 0 in a value that has a decimal point. So this one would have 4 significant digits. Here we are accenting the decimal point with the first 0. The next 2 are there as placeholders. So only the 3 non-zero digits are significant. Here we have our 3 non-zero digits, and this 0, it's a trailing 0, but there's no decimal point, so this is just a placeholder. So this one has 3. So the answer to this question would be the second and the third value have 3 significant figures. In B, all the zeros are significant in. Okay, this one, anytime we've got a 0 that's to the left of the decimal point, that's accenting the decimal point there, and so that would not be significant. Here, these 2 are trailing zeros, and there is a decimal point in the number, so these are there to show the precision of the instrument, so those zeros are significant in that value. And then this one, written in scientific notation. If correctly done, the base value, all of the digits in the base value of a number written in scientific notation are significant. So all of the zeros in selection 3 would also be considered significant. Okay, 534,675 rounded to 3 significant figures is. Okay, let's look at rounding. Well, we're going to round it to 3 significant figures. We're going to start from the left and count. There's 1, 2, 3. We're going to round on the 4. Okay, the number to the right of the 4 is a 6, so that means it's going to go up. So we have 5, 3, 5, and then we need to keep the magnitude of the number. So all of these values here that are going to get basically truncated, we're going to replace them with zeros, 0 placeholders. So now we have 3 significant figures, and the number has been rounded to 3 significant figures. So answer 2 is the correct answer for question C. Okay, in which sets do both numbers contain the same number of significant figures? Here we have 2 non-zeros That's a trailing zero. There's a decimal point, so all three of those are significant. 2 non-zeros, 2 trailing zeros, but there's a decimal point, so that one has 4. Okay, so that's not the right choice. Then we have a non-zero. We have this trailing zero with a decimal point, so it is significant, which means that these 2 zeros, which are basically captured zeros, are also significant. So this one is going to have 4. Whereas 40, written this way, that non-zero is the only significant digit. This other 0 is just a placeholder. Okay, here, that's accenting the decimal point, not significant. These are all placeholders right there, so not significant. So this one only has 2 significant digits. And then here we have these guys right here, trailing zeros with no decimal point. Those are all placeholders. The 1 and the 5 are the only significant digits, and so we have 2 there. So selection 3 is the one where both numbers have the same number of significant digits. Okay, now the thing to remember in what we're doing is that significant figures are for measured values only. In your calculations that you do, you will sometimes use values that are not measured, and there are 2 basic categories of values that fall into that are not measurements. And one is defined values. These are values that are used in defined relationships. For example, that 1 meter equals 100 centimeters. That is a defined relationship. They do not have, there's not any uncertainty in those values. The same thing with counted numbers. A counted number is when you are counting things that are basically whole units. You're not really measuring anything because, for example, if I count all the students in my room, I'm going to end up with a whole number. There's not any uncertainty in that. I'm not going to have half of a student, 3/4 of a student. I'm not going to use a measuring device to determine how many students I have in my room. I'm going to count them. And counted numbers also do not have uncertainty associated with them. So what we'll see in the next part of the discussion is that when we're using defined or counted numbers, these are exact values, and there really isn't any uncertainty with them, and therefore we don't have to adjust anything about our answers to the calculations when we're using these types of numbers. So here's some examples of what we would call exact numbers. They are either defined values or they are counted numbers.